take a look at doing a hypothesis test for a single proportion. So we're going to test the claim that the proportion of people who own cats is significantly different than 68% at a 10% significance level. The first question is, what would be the null and alternative hypothesis? Well, the null hypothesis is always that the population parameter, which in this case is the population proportion, is exactly equal to some null value. In this case, the null value is that 68% value that's given. So the null hypothesis is then that the proportion of people who own cats is equal to 68%. On the other hand, the alternative is the opposite. And we're taking the alternative here from the significantly different part. Well, different doesn't specify greater, which would be a right tail test, or less, which would be a left tail test. It actually kind of signifies either one, either greater or less. So this is going to be a two-tail test because the alternative hypothesis is that the proportion is just not equal to 68%. Not equal because it could be way larger or it could be way smaller. So this is what they're asking for. This is the null hypothesis, that the population proportion is equal to 68%, and the alternative, that the population proportion is not equal or significantly different from 68%. All right, so the second part, what is the sample proportion? So we have a sample and we're going to upload the sample to the session storage. And in the sample, we ask people, do you own a cat? And the answer is either yes or no. So let's take a look here. So I click on File. That's what I just did to open up this little file window. And then under the file window, there's this button, Upload to Session Storage, this arrow on the page. When I click it, it allows me to upload a file from my computer to session storage. The file I'm going to upload is this CSV file, hypotheses. And it's going to upload it to the session storage, hypotheses. That's from the assignment. We downloaded the CSV file. And now we're just going to click these three vertical dots and copy the file path. So now that we have the file path copied, we're going to use this syntax right here to calculate p-hat using Python. So I have a code window open here, and I'm going to type in this code syntax, but I'm going to change the file path, and yeah, I'm going to see what the actual dummy variables look like after I upload them. So let's see. So first, I'm going to type that import pandas as PD. So I'm giving pandas the nickname PD. Then I'm going to create the data frame df, which is equal to, and it's going to be PD for pandas dot read underscore CSV. So that's this read CSV method from pandas, and I'm going to feed it the file path, but I'm not going to type file path. I'm going to actually paste by doing Control V on my keyboard. I'm going to paste the file path that I just copied to hypotheses.prop.csv. And this has now loaded the data frame, and if we want to, we can look at the head of the data frame just to make sure we have it loaded correctly. And yes, this is the data frame here. I see I have cat, and a bunch of people said yes. Let's see if we load 20 observations, what it'll look like. So I put 20 into head. And okay, so the first 7 people said yes, 0 to 6. Then the 8th person said no, the 9th and 10th person, and the 11th, but then the 12th person said yes, and so forth. So I see the data there. All right, so now I'm going to create dummies using the get dummies method from pandas. So I'm going to create another data frame called dummies. And dummies is going to create a data frame with 2 columns, one for yes and one for no. So let me show you what that's going to look like. Dummies. And dummies is going to be PD dot get underscore dummies. This one here. And I'm going to do that for the data frame df, But the variable I'm using is the variable cat. Do you have a cat or not? So I'm going to do it for cat. Notice the syntax says variable, but the specific variable we want to do it with is cat. So I'm replacing variable here with cat. And then I'm going to create a variable called k, which is going to count the number of people that said yes, they own cats. So let's see, I'm going to say dummies, and then in dummies, I'm going to look for the people that said yes. So dummies, yes. And I'm going to add all those up, that sum, to find out how many people said yes. And then for the total sample size, the total number of people that were asked the question, do you own a cat? I'm going to do the length, len. That's going to tell me the length of this data series. And it's going to be dummies, bracket, yes again. So I'm looking at the number of people in this data frame of dummies, and also the number of people that said yes. So K is going to give me the sum of the yes column for the dummies data frame, and N is going to give me the total length of the dummies data frame, so the number of observations. And then finally I'm going to calculate p hat, and p hat is going to equal K over N, the number of successes divided by the number of observations. And I just want to print p hat out here. So let's print, and we're going to print a quotation. I'm going to write p hat equals, and then I'm going to add to that a string str that's just going to be the converted value of p hat, that actual variable. And when we run this now, this actually gives me the value of p hat. So p hat is actually equal to 65%, p hat. Now I'm going to look for the value of the test statistic. The test statistic, if the success failure condition is met, which it is here, because I'm looking at 68% of 500, and I'm looking at 61 minus 68% of 500. Oh, we didn't see the 500 number. I can show that to you here. If we do another code window here and I show you N is actually the number of trials, 500. All right, so let's go ahead and calculate the test statistic here. So the test statistic can be calculated using this syntax once you have the value of p hat, 65%. So now what is the test statistic? The test statistic is a z-test statistic. It's going to be p hat minus p null. P null is the value from the null hypothesis divided by the standard error. And here they give you the formula for the standard error of the p hats. It's p null times 1 minus p null divided by n. We know n to be 500. So this syntax here will actually, if you type it into a code cell, calculate the test statistic for you. So let's do it. We're from math going to import SQRT, which is the square root function. And then after we import that, we're going to set the value of p null, and the p null value is 0.68, 0.68. Remember, the p null value comes from the null hypothesis. And then once you have p null, you just say standard error, SE, is equal to, and we're going to call the square root function SQRT, and it's going to be p null asterisk 1 minus p null, and then parenthesis actually 1 minus p null. So that's p null multiplied by 1 minus p null, and I have to divide that by n. So divided by n. Remember, n was 500, but Python already knows that. So this will take the square root of p null times 1 minus p null and divide it by n. Or divide p null times 1 minus p null by n and then take the square root. And let's just see what this is equal to. So we'll do another print statement. I'll grab this print statement that I'll just copy it from here, and I'll just change it from p hat to z and print out this, or I haven't even calculated z yet. So this first I'll print out the standard error. We weren't asked for the standard error, but I'm just going to print it out anyway since I've calculated it. What we were actually asked for is the z-score. So let's go ahead and calculate the z-score. Z is equal to, and z is just equal to, we're going to have a parenthesis here, and it's going to be p hat, which we've already calculated, minus p null, which we just fed it, and we're going to divide that by the standard error. That's the formula for the value of z, the test statistic. So this will calculate the test statistic, and I'm just going to go ahead and print this out too. So instead of p hat, I'm just going to change this to the value of z, and instead of printing out p hat, I'm going to print out the value I just calculated of z. So now this is going to print out both the standard error and the test statistic. We're only being asked for the test statistic, which is z, but this will show us both. So the standard error is about 2%, and the z-test statistic is negative 1.4. All right, and the next question is, what is the p-value? So for the p-value, we're going to import the library SciPy, but the p-value actually depends on the tail of the test. So the first piece of information we're going to need is what the tail of the test is. Our alternative hypothesis is not equal, so p is not equal to 0.68. So we have a two-tail test, but we're going to set up contingency for a left, right, or two-tail test because there's 4 possible outcomes here. So if the tail is left, if it's a left-tail test, then the p-value is just the area to the left of the z-test statistic, and we can find that by doing the stats.norm.cdf. The CDF is the area to the left of z. Or else, if it's a right tail test, then the p-value is actually 1 minus the stat.norm.cdf, because that's going to be the area to the right of this z-score. Or else, if it's a two-tail test and z is less than or equal to 0, then the p-value is 2 times the area to the left of the z-score. So that's just the stat.norm.cdf. On the other hand, if it's a two-tail test, if the tail is 2 and the z-score is greater than 0, then the p-value is actually 2 times the area to the right of the z-score, which is 1 minus stat.norm.cdf. So there's 4 different contingencies here depending on what tail you have, and if it's a two-tail test, if your z-score is negative or positive. So because we have a two-tail test, we're going to tell it 2 tails, and we're going to run this code. So from SciPy, we're going to import stats. So from SciPy, import stats, and then we're going to set the tail equal to 2 for this specific test, because this specific test is a two-tail test, but we can change that if need be. And then the first thing is this first part of the if statement. If tail double equals left. So now we're going to tell it what to do if the answer for tail is left. And we put a colon. That colon is important. And then when you press enter, it's going to indent you. So the p-value in this situation is going to be equal to stats.norm.cdf, and then I'm just going to plug in the value that we got for the test statistic, the z-score. Now on the other hand, we're going to do an else if, or elif for short, else if the tail double equals quote right, and then I'm going to put a colon after this, and then I'm going to tell it what to do in this case. In this case, the p-value, or p-val, is just going to be equal to, and it's, in this case, it's the area to the right, so that's going to be 1 minus stats.norm.cdf for the value of z. And then we have a couple other cases now. So I'm just going to copy and paste this. So copy the elif statement. Copy. Then I'm going to backspace so it doesn't indent it. Put the elif in. And then I'm going to change this from right now to 2 TWO. And then I'm going to put a space after the 2 and put and to join it with another condition. And the other condition is that z is less than or equal to 0. So this is a two-tailed test with a negative z-score. And in that case, the p-value is 2 times the area to the left. So that's going to be 2 and then an asterisk for multiplication by stat.norm.cdf. And then lastly, the last situation, actually, let me copy this down. Copy and paste it here. And now it has two-tailed, and now I'm changing just from z is less than or equal to t is greater. This is all 4 scenarios. And in this case, I'm multiplying 2 times the area to the right, so that's going to be 1 minus stat.norm.cdf. And that's it. So the last thing I want to do is I just want to print out the p-value. And I'm going to print in quotation p-value. And then equal sign and space, and add to it the string str of the value I just calculated, the p-value, p-val. All right, and let's run this now. So when we run this, it gives us a p-value of 0.15. 0.15. So there I've calculated everything it asked me to calculate, and even now the p-value.